This is the last part on the video series on transducers, and I did ask you in the last video to stop the video and watch and try the review questions 8.4, see whether you can answer them. So let's go through the answers. Yeah, so describe the functions of the following transducers. NTC thermistor. So for an NTC thermistor, remember the resistance, if I plot it against the temperature, an NTC thermistor is when the temperature increases, the resistance of the thermistor decreases. Okay, so you got to learn how to describe that. And LDR also has a very similar characteristics to a NTC, but instead of temperature, what we are talking about here is your light intensity. So you also have to describe. The brighter the light intensity, the lower the resistance of the LDR. Okay, so microphone, you also have to describe it as a, a transducer, and it's also a good habit to describe it as an input or output transducer. So a microphone is a input transducer which takes sound energy and it converts it into electrical signal. Okay. A buzzer. A buzzer is an output transducer which takes an electrical signal and it changes it into a sound energy. Okay. Loudspeaker, it is a output transducer which converts, once again, electrical energy into sound energy. And finally, moto is also an output transducer which takes electrical energy and converts it into mechanical energy. Okay, so there you have it. And let's go to question 2. Okay, so draw the symbols for the following. I've kind of pre-drawn some of them. So let's mix and match them. Thermistor, now they didn't say whether it is a NTC or a PDC thermistor. I'm just going to assume that it's a NTC, so I'll draw a negative T there. So this is how you draw it. And LDR, and LDR is a light dependent resistor. A microphone looks like this. A loudspeaker looks like this. A buzzer looks like this. And your motor is a M in a circle, which looks like this. Okay, suggest a suitable transducer for the following application. So this is the story. I've got a lighting system that automatically becomes dimmer as the brightness of the surroundings decrease. Okay, so straight up, you do need a light dependent resistor. How you arrange that light dependent resistor is another story. So I'm going to pause it here. Think about how you arrange it. If I want the signal to become smaller as the brightness increases. Okay, so welcome back. I told you to go and think about how you want to hook up a circuit for this. So this is what I've come up with. This is for your LDR. So I'm going to use a, what am I doing? Pause for a moment. Okay, sorry for the technical error. For those of you who are sharp-eyed, you will have noticed that I've drawn a thermistor instead. Okay, so now that I've corrected my mistake, this is a LDR here. What happens is that when more light intensity, when the light falling on LDR increases, the resistance will decrease. And when the resistance decrease, your V out will decrease. And if I'm going to hook my V out signal to some sort of a lighting system, a lower signal would lower your lighting system here. Okay, So let's look at part B, a sensor that can detect when the temperature of the surrounding exceeds 40 degrees, when it exceeds 40 degrees. So I'm thinking of using a thermistor. Now, how am I going to hook out the thermistor when I'm talking about the temperature going higher and higher, and at above a certain point, I have a warning whether it's a light or a sound system. Okay, so think about it. I'm going to pause the video here. Okay, so this is what I've come up with. This is how I want to do it. I'm going to put my thermistor. I'm going to use a NTC, and I'm going to use a voltage divider system here. Okay, so because this is an NTC, when the temperature increases, okay, the resistance decreases, and when the resistance decreases, so the temperature is going up and up and up and up and up. That means the resistance is going down and down and down and down and down. Okay, so therefore the resistance is lowering and lowering and lowering over here, across here. That means the voltage here is also going down and down and down. And if the voltage here decreases, the voltage here increases. It's going up and up and up and up and up. So past a certain point corresponding to 40 degrees Celsius, maybe this can hook up to a LED, can hook up to a buzzer to kind of warn you past a certain threshold that it is past 40 degrees Celsius. Okay. A device, okay, so that's part B. Let's go to part C. A device that produces a sound in the presence of an electrical signal. You have a choice. You can say a buzzer, or you can say a loudspeaker. It's up to you. Okay. Just remember, if you're using a loudspeaker, remember that more often than not, you do need a amplification process before you output to the loudspeaker. Okay. Devices that uses a small current to switch on a high current motor. So when you have two, it's a switch, it switches on, and you have two types of current. One is the small, one is the large, and you're using the small to control the large. What we are talking about here is a electromechanical relay. Okay, so I hope that you gain a clearer understanding of what transducers are, the input-output transducers, and all the different kinds of transducers that I went through with you. I will be going to teach you how to use the individual transducers in class during the practical sessions. Hopefully, we've got time to finish up all the practical sessions. Okay, and I did promise you to make a video on how our relay works. I'll come up with that soon. Before you leave, as usual, my favorite YouTuber, Electroboom, he made a very simple DC motor. Okay, so you can go and search Electroboom simple DC motor, and he'll kind of tell you how to construct your own DC motor at home if you want to. Okay, so with that, I will say goodbye to you from this chapter, and I'll see you soon. Bye.